Excuse me, I had a phone call. I got some more coffee. Okay, so we're creating a table. I think that's all it really needs to be. It's a debug statement. we'll come back to this. This is this is a ridiculously hard problem. So we'll go back to it. All right, so another ridiculously hard problem. Okay, so instead we're gonna do I'm gonna show this is really unfortunate. We're just giving up, I guess. No, we're not giving up. We have to continue. We have to do this. Oh jeez. Let's go back because this is a really hard problem. So convoluted. There's so many things that could be wrong and go wrong. It's ridiculous. Alright, let's see what the SQL is doing. And I think it throws a whole bunch of SQL statements to the screen or to the console window. Okay, let's slow it down, see what it's actually doing. Okay, so it looks like it's throwing a whole bunch of SQL statements that have no title, so it's not getting the title from the pages or from the files. All of like any of these could be wrong. Shouldn't be doing this yet. Yep. Okay. All right. Let's see. Something else I was thinking of. So this is WikiHow uploading to MySQL in Jupyter. This machine is Jupyter, and in the next room is one of my servers. So let's open up MySQL and see if it's actually working. WikiHow is uploading. Let's open these in just a second, or one of these in a second. This is a really good Starbucks French roast coffee. It's freaking amazing. So it's not pre-ground. I have a grinder. I found this dump on the machine, or what was it? The Internet Archive, and it is just like the formatting is an XML, and it is just like all the other wikis, like WikiHow. I'm sorry, Wikipedia, WikiSimple, WikiQuote, Species, all of them. So just open up one of these and use. And each and every one of these is a token. So 2 means it's a header, 3 means it's a subheader. Really cool things, really cool stuff. And we can upload it to MySQL, and we can do cool things in the big app with it, I hope, in the future. Alright, in the big app, let's go back to the big app. Actually, let's open one of these and prove to you that there are actual data in the SQL. So let's build a sawhorse. So yeah, all of it is in the database, and it's easily retrieved from the database into anything. You can put this into, like in the big app, you can put this into a query for the you can query the LLMs, and they can help you with and like do things. You can do really cool things with them. Any kind of command that you can think of for an LLM on data. So that's really cool stuff. You can just simply displaying this, like going into in the big app and just displaying this for someone on his heads-up display. Cool stuff. Alright, so what I want to do is I wrote this function to find, um, I don't like how this is working. So I don't like it's using FFmpeg, and I don't like how it's using FFmpeg. We have other ways to do this, to find objects, or to store an object. So what I'm going to do is I'm going to like gut this this thing and do something else. So like I can save a handbag. So a detected object is a handbag, and it does some cool things. So laptop, remote, so cool things you can do with it. And what I was trying to do was make, like, this is when I was using FFmpeg for the video capture, and now I'm using OpenCV. So the idea is someone to have a camera on them, or have a camera on them, and then the last time it saw the object, it stores the object in SQL. It stores all this in MySQL, and then it would take all the information from MySQL in the last position it was, the last place it was, and show you an image of where it is. So the last time you had your remote, the last time you had your purse, your cell phone, computer, laptop, headphones, things like that. Baseball hat, baseball glove, a baseball bat, not baseball hat. Backpacks, any of this. So if you have any object that's COCO or COCO object detection that has with it, let's go ahead and open up all of, like, what is it actually? COCO. So here are the labels. So person, bicycle, car, motorbike, anything on this list that you can think of that could be misplaced. Last time you saw these things, I thought that would be a really cool thing to do for object detection. Thing is, there's not enough things on, or there's not enough on this list. I mean, we can train a program for someone like in a shop or something that's missing tools or something like that, and the last place they put it or had it, and it shows. So somehow we have to integrate that into our big app. So we have to call this somehow. I'm pretty sure to call this is going to be within Vision, and if visual object detection is enabled, so let's find out what's going on here. Oh yeah, I removed this text because obviously it's text. Cleaning up variables yesterday in memory, so everything looks nice. Guess I forgot to do this part. Didn't see this coming. No, that's okay. I just have done a find and replace, but oh well. Do it by hand. Okay. Forgive me, it takes a little long to compile. Nope, because it's already open. Alright, leave that open. So what I want to do too is do FTP upload of all of images that are old to like automatically upload them to my FTP server. So it looks I have 3 servers in the next room. 2 of them are little 1Us. Another one is a 4U that's like basically an i5 that I've had for a long time. The i5 has lots and lots of data, or lots and lots of memory. I wish there could be more. I'm buying some new hard drives, but I don't have enough money. And then I have the 1Us. So the Jupiter, the 1U is it has almost, I think, just a terabyte of memory in it, which it's manageable. But we can have a terabyte of, just as an example, if this were to get big, you have a terabyte of memory to store images that are not, like, a laptop doesn't have that much memory on it. So upload all of the images to FTP. So that's what I'd like to do with this, and that's what I was experimenting with. succeeded. Let's open it up. So, see the features that work so far. So, working memory, I mean, it works, but like we have to do speech commands in order to get things into working memory because there's not an actual person manning it yet. But it does, like, working memory does work. You know, like, there are functions for it, and there are methods once someone is using it to, you know, use working memory. So short-term memory, it works. Long-term memory, I don't have really anything, I don't have enough images for long-term memory. So right now it's just short-term memory. Visual memory, true. So we have cameras, or a camera. Sound memory, we have a microphone. Speech memory, that's basically transcription. LLM servers, so you can query the LLMs with voice commands. So voice commands don't quite work yet. I have a plan for getting those to work. We're going to do that sometime. I'm just trying to figure out what's most important. Transcription server. So we have our transcription server here. So this is a Python script for Whisper, and it works to transcribe text. So it sends the big app sends information to Whisper, and actually it's all around a HTML post method little server. So it sends the command to the server, then it does the Python commands or Python program, and it sends it back to the big app. I'll show you that in just a minute. Ethics check, because I don't have ethics. There's not a reason for them yet. Basically, when someone tries to do something stupid, it'll say something and it won't let them do it, or it'll give them a warning. That's going to be probably made with the federal law dump that I have. So ethics check, it'll check against federal law and probably California law once I figure out how to parse that as well. From Justia or Justia. Oh my goodness. That's a project and a half. CUDA acceleration, I don't have anything that does CUDA yet. Once I do driving, I'll probably integrate CUDA. Tensor acceleration, since the LLM server is so freaking fast, and I don't have a graphics card that does that has tensor cores yet, then we're just going to do false. But this is an idea that I had to make tensor acceleration with the graphics card and use those as, for word vectors and stuff for NLP. Visual object detection works. CUDA doesn't work. Remote doesn't work yet, because the way to send it to a remote server is new to me, and I haven't done that yet. Visual object detection, of course, this works, so it'll be able to detect different objects, people, and things like that inside of the Coco.names that I showed you later. Visual reasoning. So this is a LLM based image analysis algorithm. So it sends a query to the LLM server, which is Ollama. You can choose which one of those you want. I believe the model has to be Lava. This is a 34 billion parameter model. My graphics card can run that pretty well. So visual reasoning, sound reasoning, I don't have that quite enabled quite yet. That would be a sound, so like music, or like hitting or like birds in the background. I think that would be like suppression, like suppressing the sound, so people stay focused for focus. Speaking reasoning, not yet. reading, reasoning. I have reading working, but not reading, reasoning. That's just a simple command to the LLMs. Camera 1 is working. I have webcam. Microphone 1 is working. Speech recognition is working. Computer use, I've been thinking about it. Basically, it's gonna have a computing client on each one of the machines that you want to use, and it'll show you exactly what you want to be, like what you want to do with regard to your computer. So what you're trying to do, it'll show you how to do that, and it'll aid in using a machine like a computer. Reading is working, I believe. There's three different methods of reading. So there's that. Let's see. This is just changing the directory for visual memory and sound memory. Working memory. This doesn't actually work. I haven't found a good way of doing this. How much. So limiting how much someone can store in working memory at one time. I couldn't figure out how to quite do that in C. Basically, it's probably gonna be like how big the directory is, and through either file system or some other like boost or something. I don't think I'm gonna change the directory of the images, so it's just gonna be one directory for images for visual memory. Let's see. Long-term memory location, CUDA acceleration, remote hosting. I don't have any. So I was thinking of doing remote CUDA or remote graphics card, sending everything to a remote graphics card over the internet. I was thinking of doing this, and I'm going to do this because that'd be really cool. Once everything's working, which it is, now I have to just add a user or a person or agent for someone to use it and make that work. So probably speech recognition. Once I get speech recognition to work, or speech, what would that be called? Speech commands. There we go. Speech commands. Once I get speech commands to work. I don't know. It calls into question how I'm actually able to do this all the time, and I'm thinking about it, and it's like, do they just? I don't know. We'll see. So tensor acceleration remote. So it's a remote graphics card for tensors, for tensor cores. Object detection model. So you can change where the model is that you want to use for the main app that works right now. Just in case I don't exist or something. FFM location. FFmpeg is going to be used to compile sound memory and visual memory for and probably transcription into an actual encoded file, MP4 probably, and should display that to the user. I think that is like the best way of doing this. I'm not quite sure any other way of doing that. So just playing something to the user. I know images can work, and a little bit of sound clips can work, but combining the two is a little bit of a challenge. So I'm going to do that. Simple settings for the cameras. So I have a deep depth tech webcam. It's a 4K webcam. So 3840 by 2160 captures at FPS is 10 FPS. Thing is though, so with object detection turned off and visual reasoning turned off, with all that turned off, I can capture frames at 10 frames per second at 4K with my webcam. So there's different ways you can run this if you like. I think there's 4 different ways. And one of them is not implemented yet, but so it's 3 different ways to run the program right now. Okay, so once in microphone settings, these are really important. It instead of using an FFmpeg device, it uses Port Audio, which is a library for C++, and you can define which microphone. So it encodes. It technically isn't FLOC. It's WAV. So WAV. So lossless recording. I can change the bit rate to. It should be a sample rate, so you can change that if you like. Channels. I've only been able to get it work with a mono microphone, which is basically this little Rockstar microphone for transcription. And let's see, speech command activation is going to be Machina for now, but you can change that to anything, and it works. Speech command terminator, I chose Bellum. So this is the thing called, I think this is a transcription for war in Latin. So to end the commands in speech commands, to start it's Machina and to end it's Bellum. But you can change that to any word you like, because Whisper can pick up any language pretty much you can think of, including any language you can think of. The transcription server, so you can change where everything's being stored. Or I'm sorry, you can change where, like anywhere on the internet. You can do like an AWS or Google Cloud subscription, or you can do your own serverless apps, or your own serverless integration. I'm not sure if laptops are quite strong enough to transcribe the. I mean, like laptops. That's okay. I think it's more about the CPUs. I'm not quite sure how fast like a laptop CPU. I like a really poor laptop. But anyway, you can change on the internet where you're getting the transcription from. So I set this normal when I tested it. I set it for MacTechHipster.com, and in there would be a server that accepts requests and sends it back. Same thing with LLM host. So good thing for Llama. You can change where on the internet, or in a local machine, or in a LAN machine, where you're actually getting the LLM server and querying the LLM server. News watching, these aren't integrated yet. These are just things that I added that would be pretty cool to have in the future. Okay, so let's run it. And to run it, all it takes is the one. There we go. So up here this is TensorFlow. This is TensorFlow initializing. TensorFlow is an app is a library for neural networks in C++ and Python. And this is the this is the Whisper Flask integration like the Whisper integration within Flask for Python, so I can use C++ to make this work. So this is all just debug data or debug information for debug information. So it's writing the image. So this is object detection. It writes the image with all of the object detection stuff. Right now it looks like it only detects me, a person, from the webcam. These are height and width and X and Y values and score. So what percentage do they think that's a human? So it's 99.58, or person, which is 99.585%, which looks like it would be 100% rounded up. It's about 100%. All right, so that works. Looks like this is Flask oh my, See, Flask, it caught up. It caught a little bit of. So this is the transcription. There you go. Flask integration for or like the. It will display the analysis of this program. So the visual for vision is on another thread than the sound memory. So it keeps doing the sound transcription and capturing sound. The files are stored. Let's find those files. Files are stored in. Looks like right now it's D, and down here visual memory. So camera 1, a whole bunch of images that's captured over the last couple of weeks. Object detection. So let's go to the most recent one. And it shows me and speaking. I haven't seen here's the analysis. So the analysis, this is just random, like I have a see out statement. When it's finished, just write it. So this is a whole bunch of gobbledygook, but there you go. So there we go. So the analysis, the image shows a person wearing large headphones. The individual appears to be sitting in an indoor space, probably at home, given the casual setting and presence of what looks like a couch or bed. The person is wearing a dark colored top and seems to be focused on something out of frame, which likely could be screened for gaming or other computer activities. The headphones suggest that they might be engaged in an activity that requires clear audio output, such as playing video games or listening to music. The image has a low resolution and grainy quality. Integrating it might have been taken with a low quality camera or device. Unfortunately, that is the reality of capturing the information with webcams. They're not the greatest. Okay, and that is all we have for today, or for now. I'm going to smoke some pot because I'm that way. And we'll come back with some ideas and goals for the project because I don't know what to do with this. Funny. I didn't think I'd ever get this far. So anyway, thanks for watching, and